The rig crew needs pipe handling equipment for several reasons. One is to make a connection, to add a joint of pipe as the hole deepens. Another is to trip the pipe, to take the pipe out and put it back in the hole, so they can change out a bit, put a new bottom hole assembly in the drill string, or perform any other action that requires the drill string's removal from the hole. Crew members can make connections either by using a Kelly and a rotary table system or a top drive unit. Handling pipe, tripping it in and out of the hole, connecting joints together, and moving it around the rig floor requires a lot of equipment. Included in this equipment are the elevator, slips, tongs, power tongs, spinning wrenches, catheads, Kelly spinner, iron roughneck, rat hole, mouse hole, and air hoist. Much of this equipment is controlled at the driller's console. Transferring pipe from the deck to the rig floor may also involve special handling equipment. Notice that the Kelly is drilled down. That is, the rig can drill no deeper without adding a joint of pipe. Here's the sequence to make a connection with a Kelly and rotary table system. The driller picks up the Kelly with the hoisting system, and the floor crew sets the slips to suspend the drill string in the hole. Using large wrenches, called tongs, the crew loosens or breaks out the Kelly from the drill string. They latch one set of tongs, called the backup tongs, around the drill pipe to keep the pipe from turning when they apply breakout torque with the second set of tongs, called the lead tongs. The driller actuates the breakout cathead, which is an automatic winch on the drawworks. The breakout cathead pulls a line attached to the lead tongs and loosens the connection. With the connection loosened, the driller spins out the drill pipe from the Kelly, usually by slowly turning the rotary table. The backup tongs, latched onto the Kelly's saver sub, keep the Kelly from turning as the pipe spins out. The crew then moves the Kelly over to the new joint of pipe placed in the mouse hole, a lined opening in the rig floor that holds the joint to be added. They stab the Kelly into the new joint. They latch the backup tongs around the tool joint of the pipe joint in the mouse hole. The backup tongs keep the joint from turning as the driller spins up the Kelly into the joint, using the Kelly spinner. The Kelly spinner is a pneumatic or hydraulic device mounted near the top of the Kelly. To make up the Kelly onto the drill pipe to final tightness, the crew latches the lead tongs around the Kelly while holding the backup tongs on the pipe's tool joint box. The driller then actuates the makeup cathead on the drawworks. The makeup cathead pulls a chain attached to the lead tongs and tightens the Kelly onto the drill pipe joint. The driller, using the hoisting system, picks up the Kelly and new drill pipe joint out of the mouse hole, and the crew guides it to the drill pipe joint hanging in the rotary table. The crew stabs the new joint into the suspended joint, and the driller actuates the Kelly spinner to spin up the new joint. Once spun up, the crew latches the backup and lead tongs around the joints to make them up to final tightness. With the joints made up, the driller picks up the Kelly and drill string. The crew pulls the slips, and the driller lowers the Kelly and mates the Kelly drive bushing with the master bushing. Drilling then continues. Here's how to make a connection using a top drive. After drilling down the stand, the crew sets the slips. The driller stops circulation, and the crew breaks out the saver sub from the drill pipe using the torque wrench in the top drive's pipe handler. The driller then uses the top drive's drilling motor to unscrew the connection. The driller picks up the top drive, and a crew member opens the drill pipe elevators to allow it to pass over the box of the pipe, setting in the slips. The driller raises the top drive assembly to the monkey board. The derrick man latches the triple drill pipe stand in the elevators. The elevators pick up the stand, and the floor crew stabs the bottom pin into the drill pipe box in the rotary table. The driller lowers the top drive to stab the saver sub into the box at the top of the stand. Using the top drive's drilling motor, the driller spins up both the top connection and the lower connection at the rotary table. The rotary helpers use backup tongs to keep the connection stationary as the pipe spins. Finally, the driller begins circulation. The crew pulls the slips, and drilling resumes. Here's a crew on a rig with a Kelly and rotary table system, tripping pipe out of the hole. That is, the rotary helpers, the derrick man, and the driller are working together to pull the drill string from the hole, maybe to change the bit, or something similar. First, the crew suspends the drill string in the hole with the slips. Then, they break out the Kelly assembly. They swing the assembly over to a lined hole called the rat hole, and the driller lowers the assembly into the rat hole. With the Kelly assembly in the rat hole, the crew unhooks the swivel bail from the hook. This action frees up the elevator. Crew members latch the elevator around the joint of pipe hanging in the rotary table opening. The driller, using the hoisting system, then lifts the pipe from the hole. Usually, the driller lifts pipe until the third joint clears the rotary table opening. The floor hands then set the slips around the top of the fourth joint. Using the tongs and a spinning wrench, the crew breaks out the three-joint stand from the drill string and sets it back in the mast. Meanwhile, up in the mast, the derrickman handles the upper end of the three-joint stand. He places the top of the stand into a fingerboard, a series of projections near the derrickman's work platform called the monkey board. The driller, rotary helpers, and derrickman repeat the process until all the drill string is out of the hole. Here, the crew is tripping pipe back into the hole. The floor hands, derrickman, and the driller work together to get the drill string back into the hole. Tripping in is pretty much the opposite of tripping out. The driller sends the elevator up to the monkey board, where the derrickman latches the elevator around the top of the stand. The driller then picks up the stand a little, and the rotary helper guides the lower end over to the string hanging in the rotary table opening. They stab the stand, using the spinning wrench to spin up the stand and make it up to final tightness with the tongs. The crew repeats this process until all the string is back in the hole. When tripping with a top drive, crew members use the drive's elevator as much as they use a conventional elevator when tripping with a Kelly and rotary table rig. With a top drive, the driller can position the links and elevator close to the derrickman on the monkey board. The driller moves the links and elevator by actuating the remote-controlled link tilt mechanism on the top drive. Moving the links and elevator makes it easy for the derrickman to latch and unlatch the elevator around the drill pipe stand's top tool joint. The drilling crew can also position the elevator in any direction by unlocking the rotation lock and rotating the pipe handler assembly. Being able to position the pipe handler assembly in any direction enables the derrickman and rotary helpers to position the elevator where they need it to make a latch. The elevator returns to its original position when rotated by the drill string. One advantage of a top drive over a conventional Kelly system is its ability to ream or back ream at any position in the mast while tripping. The driller can rotate and move the string up and down through a tight section of hole. These actions can ream out the tight section of hole. Crew members use wedge-shaped gripping devices called slips to suspend the drill string in the hole. They fit around the top joint of pipe and wedge in the taper of the rotary table's opening. Slips have serrated inserts, or dies. The inserts grip the outside diameter of the suspended tubular. To set the slips, crew members place them around the pipe. The driller then slowly lowers the pipe until the slips can take up the load. The serrated inserts, or dies in the slips, firmly hold the pipe. To remove the slips, crew members grasp the slip handles And, as the driller picks up the pipe, they lift them out of the rotary table opening and set them aside. When using drill collars and other tubulars that do not have an elevator shoulder, crew members install a safety clamp above the drill collar slips. If the gripping elements on the drill collar slips failed, the drill collar would slide down. Before the collars could slide all of the way out of the slips, however, the safety clamp would hold the collars against the top of the slips. Crew members use several types of slips and spiders. A spider, like slips, suspend pipe in the hole, but spiders do not fit inside the rotary table's opening. Instead, they rest on top of it. Spiders are used instead of slips when the rotary table's bushing size is not compatible with the tubulars being run. Here you can see drill pipe, rotary slips, drill collar slips, drill pipe coil spring power slips, an air-powered tubing spider, and a 750-ton air-controlled casing spider. Crew members use each one to hold the corresponding drill pipe, drill collars, casing, or tubing. Power slips are powered by a heavy-duty, high-strength coil spring or by air. Instead of manually placing air-powered slips in the master bushing, crew members or the driller operate them by remote control. Crew members latch the elevator around the top of pipe joints in the drill string. Once latched, the driller can raise and lower pipe in and out of the hole. Crew members attach the elevator to the hook with two forged high-grade steel rods called links or bales. One end of the links fits into the link ears on the hook. Link locking arms secure the links into the ears. Crew members then attach the elevator to the other end of the links. Most elevators are hinged. Crew members open and close them by operating the latch with two handles on each side. Notice that this elevator has a tapered seat. This taper matches the taper on the tool joint of a length of drill pipe. When properly latched, the tool joint taper rests in the elevator taper and makes a firm, positive grip without damaging the drill pipe. On drill string members that do not have an elevator shoulder, crew members make up a lifting sub into the end of the joint. For instance, this drill collar does not have a shoulder. It is slick, so the crew made up the lifting sub. They latch the elevator onto the taper on the lifting sub to raise or lower drill collars into and out of the hole. On a top drive, the links holding the elevator have an air-operated or pneumatic tilt mechanism. The driller activates the tilt mechanism when the pipe is being pulled from the hole. When the top of the drill string reaches the derrickman's position at the monkey board, the driller can tilt the top of the stand of the pipe toward the derrickman. The derrickman can then unlatch the elevator and set the stand back in the fingerboard. The fingerboard is a rack that supports the top of the stands of pipe being stacked in the mast. Tongs are large wrenches that crew members use to make up and break out pipe. The crew uses 2 sets of tongs to make up and break out pipe. One set is the lead tongs. The lead tongs apply torque to tighten or loosen the connection. The other set is the backup tongs. The backup tongs keep the lower joint of pipe from turning, as the lead tongs apply torque to the upper joint. Crew members use the tongs in conjunction with special catheads or winches on the drawworks. When making up drill pipe, the driller actuates the make-up cathead on the drawworks. The cathead takes in the tong pull line, a chain in this case, and exerts a strong pull on the tong arm. This pull causes the lead tongs to apply torque to the joint to make it tight. When breaking out pipe, crew members use the breakout cathead on the drawworks. The breakout cathead takes in the tong pull line and exerts a strong force on the tong arm. This force breaks out the pipe connection. This is a hydraulic cathead. It's an auxiliary torquing device. It helps crew members break out and make up very large drill collars. Very large collars require a lot of make-up torque, so much in fact that the breakout cathead's pulling force may not be strong enough. One solution is to use a hydraulic cathead with rigged tongs. The hydraulic cathead includes a hydraulic cylinder housing and a wire assembly. The hydraulic cathead is controlled remotely by the driller from his position on the rig floor. This device produces a safe, powerful, and steady tong line pull to break high torque connections. Manufacturers make many types and sizes of power casing and tubing tongs. Crew members use them to connect casing and tubing couplings. Power tongs allow fast and uniform makeup and breakout of connections. The makeup torque can be preset by adjusting a built-in pressure relief valve. Accompanying a rig's regular tongs is the spinning wrench or pipe spinner. Crew members use a spinning wrench to spin up or spin out pipe connections. For example, once a connection is lubricated and stabbed, they place the spinning wrench on the upper joint and activate the wrench. Rollers engage the pipe and turn it rapidly until shoulder meets shoulder. Then, the crew latches the regular tongs to make up the joint to final tightness. They can also reverse the direction of the spinning wrench to spin out a joint that they loosened with the regular tongs. To spin up or spin out the Kelly, most rigs have a Kelly spinner. The Kelly spinner is hydraulically or pneumatically operated. When the driller activates it, the Kelly spinner rapidly spins up or spins out the Kelly from a joint of drill pipe. Crew members attach it to the Kelly below the swivel. Some rigs have this vertical pipe handling device. The manufacturer calls it an iron roughneck. It combines the lead tongs and backup tongs into a single package. The built-in tongs are hydraulically powered, self-contained torque wrenches. They allow the crew to make up and break out joints without using catheads on the drawworks. An iron roughneck mounts on the rig floor and rolls into place on tracks. It reduces the labor involved in making up and breaking out pipe. However, crew members have to maintain it carefully to ensure proper operation. Some rigs, working in rough seas or harsh environments, use an automated pipe racking system. The rig owner mounts the racking system on the rig floor and to the mast. The device racks pipe stands in the mast's fingerboard. The operator controls the pipe racker from a remote station and views the operation from a camera located directly above the fingerboard. The pipe racking system works in conjunction with the iron roughneck. Another type of pipe racking system found on drill ships racks the drill pipe stands in horizontal racks outside the mast or derrick. Crew members place the Kelly assembly in the rat hole when they are ready to make a trip. The rat hole is made of large diameter pipe that extends below the rig floor. The rat hole also protrudes above the rig floor to make it easily accessible. The mouse hole is a length of large diameter pipe that extends below the rig floor. The crew places a joint of drill pipe in the mouse hole in preparation for adding it to the drill string. Crew members use an air hoist to move pipe and other drilling equipment around the rig floor. An air hoist is an air-powered winch that contains a reel of wire rope. When a crew member actuates the hoist, it takes in rope to lift a piece of equipment. It also has a wire rope guide that the crew member uses to keep the line from winding unevenly on the reel. Usually, rigs have several air hoists placed around the rig floor. Some rigs use an automatic pipe transfer system to pick up and lay down tubulars. The pipe transfer system also moves tubulars onto the pipe deck. The automatic pickup and laydown system, PLS, hoists tubulars from the V-door position to a vertical position. The PLS consists of the guide rail assembly, hydraulic lift arm with slew capability, carriage, winch, and control console. The system can pick up or lay down drill pipe, drill collars, or casing joints weighing up to 7,000 pounds, over 3,000 kilograms, and up to 20 inches or 500 millimeters in diameter. The pipe deck machine, or PDM, has a hydraulically controlled mechanical arm. This arm moves tubulars between the pipe rack on deck and the drill floor. The PDM picks up the tubular from the pipe rack, moves perpendicularly on a floor track, and then lowers the tubular to a conveyor. The conveyor carries the pipe up to the V-door. There, the PLS picks up the tubular and moves it to the elevator for hoisting. Pipe transfer systems are used on jackups, semi-submersible, platform, and land rigs. The driller controls the rig's operations from this position at a console. The console is usually on the rig floor, either in the open next to the drawworks, or, on the latest rigs, in a control house on the floor. One important gauge on the instrument panel is the weight indicator. It tells the driller the weight on the bit and the hook load. The hook load is the weight that is suspended from the traveling block and hook. Weight on bit is the portion of the bottom hole assembly weight acting on the bit. Several gauges show the driller pump pressure, pump rate, rotary speed, rotary torque, and tong line torque. The driller's control panel allows the driller to operate the rotating, hoisting, and mud pump equipment on the rig. For several reasons. One is to make a connection, to add a joint of pipe as the hole deepens. Another is to trip the pipe, to take the pipe out and put it back in the hole, so they can change out a bit, put a new bottom hole assembly in the drill string, or perform any other action that requires the drill string's removal from the hole. Crew members can make connections either by using a Kelly and a rotary table system or a top drive unit. Handling pipe, tripping it in and out of the hole, connecting joints together,